Hello, I'm Ashrita, student of Sri Venkateswara College of Engineering, 8th semester, Department of ECE. This video is about hydrogen as potential primary energy fuel for municipal solid waste incineration for sustainable waste management. Contents: Introduction, History of Technology, Methodology, Block Diagram, Flowchart, Literature Survey, Application, Result, Conclusion and Reference. Introduction: Hydrogen can be a potential primary energy fuel for municipal solid waste incineration for sustainable waste management. Hydrogen is a clean and renewable energy source that produces no harmful emissions or pollutants when burned. It can be produced from various sources, including renewable energy sources such as solar and wind power, as well as from fossil fuels capture and storage technology. Firstly, it can reduce the carbon footprint associated with waste management as hydrogen combustion produces only water vapor and no carbon emissions. This can contribute to global efforts to mitigate the climatic change. Second, the efficiency of the incineration process can be improved by employing hydrogen as a primary energy fuel. Compared to the other fuels, hydrogen has higher energy content. Introduction as follows. Hydrogen provides more energy for each unit of fuel used. As a result, there may be greater ability to recover energy from municipal solid waste and a lesser need for fossil fuels. Managing solid waste is one of the most important tasks for municipalities and the organizations work. This method would be less pollutant. The combustion of municipal solid waste may generate a sustainable volume of heat energy, which can be captured and turned into power by using hydrogen fuel cells. Fossil fuels by using hydrogen as a primary energy fuel in MSW, that is municipal solid waste incineration. History of technology. The history of this idea can be tracked back to the early 2000s, when the Indian government recognized the need of sustainable waste management practices and began promoting the use of alternative energy resources such as hydrogen. In 2017, the Indian Institute of Technology, Delhi, conducted a study evaluate the feasibility of using hydrogen as a primary fuel for waste incineration. The study found that using hydrogen could reduce the emission of carbon dioxide and other pollutants, while also increasing energy efficiency. In recent years, various research and pilot projects has been conducted in India to explore the feasibility of using hydrogen as primary energy fuel in MSW incineration plants. Literature survey as the first paper, Waste to Energy Technologies Using Multi-Criteria Decision Analysis for Municipal Solid Waste Management. The advantages of the paper are waste to energy technologies can reduce the volume of municipal solid waste and the need for landfill space. A disadvantage of the page is there may be concerns around emissions and environmental impacts associated with the waste to energy technologies, including air pollution, greenhouse emissions, and ash disposal. The other paper is GIS-based waste to energy improved solid waste management practice for waste collection. The advantages are provides accurate and real-time data on waste collection, transportation and disposable, allows for more efficient and effective waste management. This technology may require significant financial investments, which may be challenged for local governments or private investors. The third paper is about developing sustainable solid medical waste management based on enterprise resource planning in general hospital. So the advantages are sustainable solid medical waste management can help minimize the environmental impact of healthcare facilities, reduce healthcare associated infections and ensure compliance with local and national regulations and guidance. The disadvantages are there may be challenges in effectively implementing and integrating the ERP system with existing healthcare information management systems. Methodology. The use of hydrogen as a primary energy fuel can improve the sustainability of the process as it produces fewer greenhouse gas emissions compared to the traditional fossil fuels. Here are the steps for municipal solid waste incineration for sustainable waste management using hydrogen as a potential primary energy fuel. Waste collection. Waste collection. The first step is to collect the municipal solid waste for households and business in the areas. The waste is sorted to remove the recyclable materials such as plastic, paper, and material. Waste preparation. The municipal solid waste is then prepared for incineration by shredding and grinding it into small pieces. This process helps to increase the surface area of the waste, making it easier to burn. Incineration. The prepared municipal solid waste is then burned in a large incinerator. Hydrogen gas is used as primary fuel for incinerator. The heat generated by burning the waste is used to produce the steam, which drives a turbine to generate the electricity. Emission control. The emissions from the incinerator are controlled using combustion of scrubbers, filters, and electrostatic precipitators. This technology helps to improve the pollutants such as particulate matter, sulfur dioxide, and nitrogen oxide from the emissions. Energy recovery. The heat generated by the incineration process is used to produce the steam, which is then used to generate electricity. The electricity produced can be used to power homes, businesses, and other facilities in the area. Ash management. The ash generated from the incineration process is collected and decomposed in an environmental responsible manner. The ash may be used as construction material or disposed of in a landfill. Diagram. Electrolyzer. The process of the hydrogen generator adopts the latest water electrolysis hydrogen production technology. The process flow is simplified. The startup time of the device is short and the response time is fast. So electrolyzer is used in this particular concept. Air blowers. Air blowers are devices designed to take in air at the inlet and expel it at the outlet. While increasing both the speed and volume of the air, blowers are used to mix air and gas provided combustion air inclination. Temperature data logger. Temperature it is used to detect the temperature inside the inclinator while before the waste edge and after. Ashtray is used to collect the ash after the incineration. Incinerator is a combustion chamber where all of these inputs go and burns the municipal solid waste. Flowchart. The water is passed through the electrolyzer where electrolyzer gives hydrogen and oxygen. Hydrogen is given to the incinerator through the air inlets. Burner is used to burn the municipal solid waste and municipal solid waste is given as input. After the combustion, the incinerator gives ash as the output and the energy generated during the combustion is given for heat generation, power generation, and many more. So, hydrogen as potential primary energy fuel for municipal solid waste incineration has various applications that can contribute to sustainable waste management. Some of these applications include electricity generation, heating, transport fuel, energy storage, chemical production, hydrogen fuels. Electricity generation. Hydrogen can be used to generate electricity by fuel cells or combustion engines by using hydrogen generated from MSW. Can be produce electricity without generating additional greenhouse gases, thereby reducing carbon emissions and contributing to sustainable waste management. Heating. Hydrogen can be used for heating purpose, either for industrial process or for residential heating. By using hydrogen generated for municipal solid waste, we can produce the heat without generating additional greenhouse gases, thereby contributing to sustainable waste management. Transport fuel. Hydrogen can be used as fuel for vehicles powered by fuel cells or combustion engines. Using hydrogen as a transport fuel can reduce air pollution and greenhouse emissions, contributing to sustainable waste management. Energy storage. Hydrogen can be stored and used as backup energy source for intermittent renewable energy source such as solar and wind. By using hydrogen generated from municipal solid waste as an energy storage medium, we can increase the reliability and resilience of the renewable energy system, thereby contributing to the sustainable waste management. Chemical production. Hydrogen can be used as a raw material for the production of various chemicals such as ammonia, methanol, and hydrogen peroxide. By using hydrogen generated from municipal solid waste, we can produce chemicals without relying on fossil fuels, thereby reducing carbon emissions and contributing to sustainable waste management. Hydrogen fuel cells. Hydrogen fuel cells can be used to power various devices such as portable electronic devices, remote sensors, and unmanned vehicles. By using hydrogen generated from municipal solid waste to power fuels, we can reduce the environmental impact of these devices and contribute to sustainable waste management. Overall, the use of hydrogen as primary energy fuel for municipal solid waste has various applications that can contribute to sustainable waste management. As a potential primary energy fuel for municipal solid waste incineration has several advantages including clean energy. Hydrogen is a clean burning fuel that provides only water as a byproduct when combusted, which reduces harmful greenhouse gases emissions. Renewable energy. Hydrogen can be provided from renewable energy sources such as wind and solar power, making it a sustainable and environmental friendly energy source. Energy efficiency. Hydrogen has high energy content per unit weight, which means that it can provide more energy for the same amount of fuel that traditional fossil fuels. Reduce dependency on fossil fuels. By using hydrogen as a fuel, we can reduce our dependence on fossil fuels, which are finite resource and can have negative environmental impact. Increased energy security. Hydrogen can be produced domestically, reducing dependence on the foreign source of energy and increasing energy security. Versatility. Hydrogen can be used in a wide range of applications including power generation, transport fuel, heat generation, and chemical production. Reduced waste. By using municipal solid waste as a feedback for hydrogen production, we can reduce the amount of waste that gives to the landfills, contributing to sustainable waste management. The results. The figure shows the testing of the flame length of the burner with different orifices. Left side visible image and right side FLR image. A burner with an orifice of 0.4 mm and B shows the burner with an orifice of 0.5 mm and C shows the burner with orifice of 0.6 mm and D shows the inside view of incinerator with burning flames. So in the figure 4 we have seen the residue sample of 7 different incinerated waste under test, a sample heating in the oven for calculating the moisture content of fly ash, and C shows a sample heating in the muffles furnace for calculating the loss of ignition of waste residues. The graphs shown describes the temperature graph from the homogeneous respective wastes. Here we'll be calculating the different types of wastes homogeneously to get the particular graph. The second graph describes the temperature data at the 3 different positions of empty incinerator using hydrogen as combustion fuel. Conclusion. The study examines the feasibility of using hydrogen as a primary fuel for waste management using a shaft-type waste incinerator chamber with specially designed burners. Different combinations of solid waste with varying moisture contents were used. The results shows that maximum temperature of 850 degrees Celsius was achieved for municipal solid waste with 77% moisture content and 68 liters of hydrogen was consumed for 1 kg municipal solid waste, translating to 204 Wh of energy consumption. The reduction in the weight of LOI of treated waste were within 86 to 94% and 1.74% to 6.41% respectively. Meeting incineration performance standards, the system worked efficiently for diverse municipal solid waste with a maximum moisture content of approximately 80%. High moisture content required more hydrogen and time and moisture content of 90% reduced performance. The temperature and the concentrated flame of hydrogen contributed to the optimum performance at high moisture content. These are the papers that I have referred for the above seminar topic: hydrogen as potential primary energy fuel for municipal solid waste incinerator for sustainable waste management. Thank you.